Okay, we're going to look at this homework problem that we didn't have time for in class also. So the instructions, I think, say to use logarithmic differentiation to find dy dx, but you should recognize, even if you're not told to use logarithmic differentiation, that that's what you need here. And the key to recognizing that is that you're trying to find the derivative of something that is a variable to a variable power. So that's on the left side of our equation here, where I have y to the x. Variable to a variable power. We don't have one of those basic derivative rules that applies to that. So the way you handle that is logarithm, use that property of logarithms. And then I'll also need to use implicit differentiation to finish this. Okay, so we start by taking the ln of both sides, both entire sides, and then you're going to use properties of logarithms to simplify that. So we've used the property of logarithms on the left side before. So ln of a to the b is b times ln of a. On the right side, there are a couple of ways you could do that. You don't have a variable to a variable power on the right side of the equation, so you don't technically have to use any properties of logarithms on the right side of the equation to simplify, but there are some properties of logarithms on the right side that help and make things a little bit simpler if you remember those properties of logarithms. So I'm going to write those over there. One of them is that the logarithm of the product of two things, so a times b, can be rewritten as ln of a plus ln of b. And so because I have x cubed times y, with the way that's written, I would have to use product rule on that right side. But if I use this property of logarithms to separate that out, then I can avoid having to use product rule. So those would be the two that are relevant for this one. There is another property of logarithms kind of related to that. I'll go ahead and write it here, that you wouldn't use on this problem, but maybe some other problems. So ln of a divided by b is ln of a minus ln of b. Okay, so I'm going to go ahead and use those properties of logarithms. I haven't actually done any calculus yet. I'm just doing algebra at this point. On the left side, I'm going to use the property about the powers. That's really why we're using the logarithms here, is that property about the powers. So on the left side, I'm going to rewrite that as x times ln of y. And then I'm going to go ahead and use the property about the product ln of a times b on the right side, just to make it a little bit easier since we're doing logarithms here anyway. All right, so I can separate that right side into ln of x cubed plus ln of y. I just used that second property of logarithms that I've written over there on the right hand side. There is one more property of logarithms you could use. You could go back and use that property that I have highlighted there that we use on the left side if you want. This ln of x cubed is of the form ln of a to the b, so you could use that property on that. Since we're using lots of properties of logarithms here, I can go ahead and do that on this one as well. So at this point, I still have not done any calculus. All I've done is algebra. But the preparation, the reason I did all that algebra was to prepare for being able to do the calculus. So again, the logarithm that I took for both sides, the real reason I had to do that was that I had the variable to a variable power at the beginning of the problem. The other things that I did with the logarithm on the right-hand side of the equation were really just extra things you could do if you wanted to make the problem easier. But the left side, it's really important that you recognize using that ln to rewrite that. Okay, so what I'm after here, I haven't done any calculus yet, so what I'm after here is some actual calculus. I'm supposed to be finding dy dx, and since this equation is not solved for y, you have to use implicit differentiation. So you're going to find d dx of the left side and d dx of the entire right side. Okay, and so here we go. On this left side, I'm going to need product rule because I have product of x times ln of y. So I'll go ahead and write out some structure here for product rules. So I'm going to have the derivative of the first, so that's the derivative of the x, which will just be 1, times the second function, so that'll just be ln y, and then plus the first function, that's just x, times the derivative of the second. And here's where I'll be using the implicit differentiation, and I'll have my extra dy dx that shows up when I do this step. So derivative of ln of y, derivative of ln of a variable is 1 over that variable times the derivative of what's inside the logarithm. If I just had ln of x, I wouldn't have to do anything about that. But here, because I have ln of some function of x, because I have ln of y is a function of x, I'm differentiating with respect to x, that's when I need that extra dy dx. So sometimes students just pop in that extra dy dx whenever, and they're not really sure when it comes in there or not. But the key to recognizing that is that that pops in there, and that's it's really chain rule. So it's times whatever you get whenever you're differentiating something that involves y. So you're differentiating the part that involves y. Okay, so that is all just from the left-hand side of the equation, the derivative with respect to x of x times ln y. All right, so I need to go back up and then differentiate each piece on the right side. Okay, so the first term on the right side, the 3 times ln of x, I don't have anything strange going on there. That's pretty straightforward derivative. The 3 just comes along, and then the derivative of ln of x is 1 over x. All right, good to go on that. And then plus, and then the derivative of my next term. Here I'm going to be differentiating something involving y again. So derivative of ln of a variable is 1 over that variable, and then times the derivative of what's inside there with respect to x. So that's what the dy dx is, derivative of y with respect to x. So again, right there where I'm differentiating some part that involves y, that's where I end up with those extra dy dx's on those parts of the problem. All right, I'm going to go ahead and write a line without a bunch of parentheses here. So ln of y plus, on this next term here, I might make that x over 1 times 1 over y. So you can just write that as x over y times dy dx equals, I'll make that next term there 3 over x, kind of same idea, 3 over 1 times 1 over x plus 1 over y dy dx. Okay, so at that point I've found the derivative. I just need to now do algebra to solve for dy dx. So I have dy dx terms on both sides of the equation. I need to get them both on the same side of the equation. So you have some choices about how you do that. I'm going to choose to subtract x over y times dy dx from both sides. So that'll get all of my dy dx terms on the right side. And then I'll also want to get all the terms that do not involve dy dx on the other side of the equation. So I'm going to need to move this 3 over x to the other side of the equation. So I'll subtract that also from both sides. Okay, so what do we got here? ln y minus 3 over x equals, all right, and then on the right side I'm going to go ahead and factor out the dy dx. And I'll be left with 1 over y minus x over y. And then I need to finish and solve for dy dx. So there's a couple extra steps of algebra you could do here if you want. One thing I might notice is that these two fractions in here happen to have a common denominator. That's not always going to happen. Since they do have a common denominator, you could rewrite that. I'm sure the textbook probably did in its solution here. I think I'll go ahead and do that just because I think it makes the answer a little bit nicer. All right, and then remember you want to try to solve for dy dx. So I have two choices now about how I do that. I could divide through by that fraction, 1 minus x all over y. The problem with that is that I end up with fractions within fractions, which is okay. It's not really wrong, but if you're going to do anything more with this derivative, that makes things kind of complicated. So I'm actually going to erase that part. And instead of doing that, what I'm going to do is multiply by the reciprocal of the fraction that I have over there on the right side. Okay, so I'm going to multiply both sides of the equation by the reciprocal of this. So dividing by a fraction is the same thing as multiplying by the reciprocal of that. So I'm going to multiply both sides of the equation by y over 1 minus x. All right, so both sides of the equation. So on the left side, I'm going to go ahead and leave that factored out. I'm going to put it out front, y over 1 minus x times the quantity ln y minus 3 over x equals, and then on the right side, the whole point of why I multiplied by that fraction was to get it to cancel with that fraction that's there. So on the right side, I'm just left with dy over dx. The book might have done some other algebra. There's a couple terms inside the parentheses. You could get a common denominator there. You could also distribute through the parentheses. So there's a lot of different ways you could write this answer. But that's probably how I would leave the answer.